definition. Okay. So if suppose some example is given, so if f of x, such example you take, and limit is denoted as capital L or LIM. Okay, you can see there in definition. So if suppose f of x is equals to x square minus 1 by x minus 1. Okay, and if suppose we will put the value of x equals to 1, we will get 0 by 0. So if suppose we will directly put 0, 1 in place of x, it will become 0. So there is a difficulty to obtain some solution. So in this case, what is that? So x is not taken exactly 1, but x is taken just nearest to 1. Okay. So if suppose it is taken nearest to 1, either it may be less or it may be more, but nearest to 1. So if suppose the value of x is 0.5, and in the following solution x square minus 1 by x minus 1, if you will substitute there the value of 0.5, then you will get 1.50000. So in this way, limit is that the same value taken nearest to the particular value. Okay, not exactly the same value, but nearest to the value. Similarly, some of the other examples will be given below. Now, what is continuous function? As the word itself, limit means it will limit to certain value, but continuous function is it will continue. Okay, it will continue. There is no ending value. Then come to limit of a function. So it is denoted as limit x tends to c. C is constant f of x, where the value of x will vary and equals to L, that is the value or the result. Okay. Then here if some so following formula is applied here. If suppose here example 2, if you will see, then find out the limit of x square when x tends to 2. Okay. Here simply no simplification is there. So if suppose we will find out the value x tends to 1, x tends to 2, that means it will reach to 2. It will reach to 2. It will be nearer to 2, but not exactly 2. Okay. So if suppose here in table you will see x, suppose if it is 1 in the following equation x square. Okay. So it will be denoted as limit x tends to f of x is equals to x square. Okay. So x equals to, if suppose 1 it is taken, that means x should be less than 2, not exactly 2, but nearest to 2. So if x is 1, f of x, when you will, f of x means we have substitute the value of x. So f of x is 1, so it will be 1 itself. Then similarly, if x is 1.4, it will be 1.96 as per the square. Okay, x square. Similarly, if x is less than 2, x is less than 2, sorry, x is greater than 2, sorry, x is greater than 2, that means from the larger value to the nearest 2, taking from 3. If suppose x is 3, if you will substitute in the value x square, so 3 if it is taken, f of x is 9. Similarly 2.6, 2.6 ka square, it will be 6.76. Similarly, it will reach to 2.001, but not exactly 2. Okay. So here it is taken from the positive side and from the negative side. Okay. Negative side means in the first case, it is taken less than 2. The values are taken less than 2, and second case, the values are taken more than 2. Okay. So if suppose the same equation is solved according to the limit, so limit x tends to 2 minus, that means negative form. Okay, that is, if it is negative, it is called left hand limit, and if it is positive, then it is called right hand limit. Okay, so here if you will see, limit x tends to to negative x square, that is equals to 4 if you will put the value of 2. Okay, then same, if limit x tends to 2 plus x square, that is equals to 4. That means you have to put the value. X tends whatever x will tends, that we will put the value. So here one example is given. You see these examples, these are further solved in another form also. Here in a tabular form it is given directly, you are substituting the value nearest to that value, but these solutions are solved in another way also. Okay, so here see, if suppose f of x is equals to x square minus 4 by x minus 2, where x tends to 2. Suppose you see why it is given like that. You see, if directly if you will put the value of 2 here, so 2 square minus 4. 2 square means 4. So 4 minus 4 will become 0. Then x minus 2. If it is taken 2, that means it will become 0. So no solution is possible. And that's why limit is giving that solution that take the nearest value of that particular value. Okay. So if suppose one side is, that is negative. Okay. Less than, x is less than 2, that means it is the negative side. Okay, and if it is greater than 2, that is the positive side. Okay, so here you see first one, less than 2, that is if x is taken 1, in the following solution, that is x square minus 4 divided by x minus 2. In that value, in that equation, if you will put the value 1 here, so it will obviously come 1. Okay, if you will see 1 square minus 4 divided by 1 minus 2 minus that is minus 3 minus 1. Okay, so it will become, first in case you see 1 is given, so it will become 1, then 1.4, 3.4. Similarly, if you will substitute, continuously substitute 1.47, here is no restriction of taking value. Okay, here it is written 1.4, 1.7. You can take it as 1.3 also, 1.5 also. No restriction. Okay. In this way, second greater less than 2 is taken. Now, here you see again it is given limit x tends to 2 minus f of x equals to 4, and limit x tends to 2 plus f of x is equals to 4. Okay. So 4 is the value. Now, as I was telling you, the same equation, same type of equation can be solved in other way. Here, it is solved in according to this one, you see, without taking the formulas. One equation is given, f of x, if suppose x square minus 9 minus x divided by x minus 3 if it is given. So here, what is done according to first principle? This is according to first principle. So, by the method of substitution, first step is that take x tends to a and h tends to 0. Okay. Then what you will do for f of x, x square minus 9 by x minus 3. Now here in place of x, you will write 3 plus h. Okay. Where x tends to 3, then h tends to 0. X tends to 3 means according to the formula, x will be constant. Okay, that is a. A is a constant. Then h tends to 0. Now, simplification, in place of x, what is substituted? 3 plus h. Okay, 3 plus h. So, f of x equals to, now it will become f of a plus h. A here is 3, constant. Okay, so f of 3 plus h equals to 3 plus h square minus 9 by 3 plus h minus 3. X, the value of x is substituted with 3 plus h. Okay. Now 3 plus h whole square formula, as per the formula it will be expanded. So it will become, you know the formula. Okay. If you don't know the formula, just by heart the formulas, because formulas are important. Okay. So as per the a plus b whole square formula, It is expanded, so it will become 9 plus h square plus 6h minus 9 divided by h. Now h will cancel wherever h is possible to cancel, wherever simplification is possible, you will simplify it. So afterwards, after simplifying, it will become h plus 6. Okay, h plus 6. Now what is the value of h is given? The value of h is 0. Okay, so here now at last h plus 6 is given, so put the value of h, sorry, put the value of h as 0. So f of 3 plus 0, 3 plus h was given, so 3 plus 0 is equals to 3. Okay, 3 plus 0 equals to 3 as per the previous one. Now here what we have got the answer, that 6, h plus 6 we have got. So the result, final result will be 6. 0 plus 6, it will come 6. Okay, so that is x tends to, the limit x tends to 3, f of x is equals to limit h tends to 0, h plus 6 equals to 6. Okay, this is according to the first principle. It is not mentioned here, I think, but it is according to the first principle. Now, some of the properties of limits are given. So, as per the properties, some of the equations are solved directly. Okay, so here you have to remember the properties. If such a short questions can come where direct by according to the property, direct it can be solved. Okay, now if c be any constant and limit x tends to a, f of x is given, then the followings are true. How it is given, you see, the limit of a constant is constant. Okay, if suppose limit x tends to a, any constant number, suppose limit x tends to 1, k is a constant, suppose 12, answer is directly 12. Okay, k is a 12, so k, simply every whatever largest number is there, limit of any constant is constant only. Okay, then limit of any constant multiplied with any function, okay, it will become k into limit x tends to a, f of x function. Okay, then limit of a sum or difference is the sum or difference of the limits. That means it can be separated. Okay, it can be distributive. If suppose in bracket limit x tends to a is given, in another bracket f of x plus or minus g of x, another function. If two functions are added or subtracted together, they can be separated as limits. Okay, they can be separated as limit x tends to a, f of x plus or minus limit x tends to a, g of x. Okay, then next property says that the limit of a product is the product of limits. Similarly, if two functions are multiplied, okay, with a single given x tends to a, so it can be separated, it can be distributive in this form. Limit x tends to a, f of x into limit x tends to a, g of x. Two functions are there. Then if suppose two functions are divided with each other, okay, if they are divided with each other, it can be again shown in this way, that is limit x tends to a, f of x divided by g of x. If it is given in this way, it can be separated as limit x tends to a, f of x by limit x tends to a, g of x. Okay, where here one condition is there, where the denominator or the divider should not be equal to 0. Okay, then now if suppose nth root of function, any function is given. Okay, so in this case limit x tends to a, nth root of f of x, any function is given, it can be shown in this way, that is nth root of limit x tends to a, f of x for all positive integers values of n. That means all should be positive, no negative integers should be there. Okay, then if suppose limit x tends to a, x to the power n is given, so it is direct value you can put, that is a to the power n. Okay, directly It is given, and n should be a positive number. Then limit x tends to a log f of x. In that case, it can be written as log limit x tends to a f of x. Then if suppose exponential is given, exp exponential. Okay. So limit x tends to a exponential of sorry, f of x is given as exponential of limit x tends to a f of x. Okay. Then some standard limits are there. As per the standard limits, direct answer will come. Okay. Then if suppose x limit x tends to a x to the power n minus a to the power n by x minus a, if it is given. In the previous example, if suppose x square minus 4 was given divided by x minus 2. So if suppose if it is given in that form, so directly it will be n into a to the power n minus 1. Directly you will get the answer. Okay. And here n should be a positive integer. Then limit x tends to 0, 1 plus x whole to the power 1 by x. Directly answer will come e. E is the exponential. Then limit x tends to 0, a to the power x minus 1 by x log log a to the base e. Direct answer. Okay, a is a constant here. Similarly, limit x tends to 0, it will become a, sorry, the limit x tends to 0, exponential, that is e to the power x minus 1 by x. Directly value equals to 0. Okay. Then limit x tends to 0, log 1 plus x by x is equals to 0. Here you can see as per the properties, some examples are given. Okay. Some examples are given. You see first question, that is a limit x tends to 2, 9. Okay. So here you see it is the limit of constant. So as per the property, limit of any constant is equals to constant. Now constant here is 9. So the value ultimately is 9. Okay. And various other examples are given according to the following property. Okay. Go through it. Then now another method is there to solve the limit, that is of factorization. You might have read, you might have studied in factorization method in class 10 also, in plus 2 also. If you are commerce student or science student, this factorization method you might be knowing. Okay. So factorization method, nothing but you have to factorize certain part of the equation. Okay. So now for the steps are, here you can see, if suppose some functions are given. So if suppose this function is given, limit x to the x limit x tends to 5, x square minus 3x minus 10 by x square minus 6x plus 5, if it is given. Okay. So after factorization, it is grouped. After factorization, grouping will be there. Okay. Here 3x is grouped as 2x 2 minus, that is 2 plus 2 minus, sorry, plus that is minus 2 minus 3 is given. Okay. It is factorized in that way. Now after factorization, it is grouped and then it is solved. Okay. Now putting the value of x, you will get 7 by 4. Now some of the irrational questions are also given. So irrational means it is the example of irrational equation. Okay. Irrational, here it cannot be solved unless and until you will rationalize it. Okay. So as per the rationalization method, what you will do, first rationalize the containing square roots, then simplify, then put the value of x. If suppose in this example limit x tends to 0 is given and root of 1 plus x minus root of 1 minus x by x. Okay, if it is given. So next step is to rationalize. Rationalize means here you see whatever the value is given on the root part. Okay, so here you see, take 1 plus x as a, 1 minus x as b. Okay, root of a minus root of b. For instance, okay, so if a minus b is given in a root, then what you will do, you will same multiply with the plus symbol and divide with the minus symbol, divide it with the same symbol. If it is given minus, so here what is given, you see, multiplied by root of 1 plus x plus root of 1 minus x. Okay, so in this way, what it will be done, you see, so the numerator part, it will become square. 1 root of 1 plus x square and root of 1 minus x square whole square. Okay, so if root is squared, that means root is removed. You know that principle. Okay, so if root is squared, root is removed. So now in next step, root is removed from the numerator. So it will become 1 plus x minus 1 plus x. Okay, and the denominator will remain the same, x into root of 1 plus x plus root of 1 minus x. Okay, then simplifying the numerator part, that is plus 1 and minus 1 will be cancelled, and plus x, 2x is remain, and the numerator part remains the same, and afterwards wherever the solution is stopped, okay, wherever solution is stopped, there you will put the value of x. Now from here itself, no solution can be possible. So put the value of x here. So x tends to 0. So now putting the value of 0 in place of x, here you see 2 into, that is 2x is the 2x was there. So now x was cancelled here. In this part, x was cancelled and it remained 2 by root of 1 plus x plus root of 1 minus x. So after substituting the value of x, it will become answer 2 by 2, that is equals to 1. Okay. Then if suppose x tends to infinity is given, it has another solution also. In case of infinity, solution is different. How it is different, you see, that in numerator part and denominator part, okay, they are taken as separately. So in numerator part, you see whichever is the highest power, okay, highest power divided with that, okay, divided with that, both the, that is the numerator and denominator. So first of all, here you see x numerator part, you can see highest power is square, okay, highest power is, that is highest power is x to the power 3. Okay, so x to the power 3 is divisible to all the parts. Okay, so 2x square by x to the power 3 plus 5x by x to the power 3 plus 1 by x to the power 3. Okay, all numerators. Then similarly denominators, 3x cube divided by x cube minus 2x by x cube plus 4 by x cube. Okay, after simplification, wherever cancellation is possible, cancel it, and after that put the value of x tends to infinity. Okay, after getting this one, okay, after getting this one, put the value of x, that is infinity, x tends to infinity. So wherever x is there, put the value of infinity and you will get this answer. Okay, then come to next part. If suppose some other examples, you go through this. Okay, already I am. Now continuity. Continuity means how you will know that a particular equation is a continuous process or not. Okay, so by applying the first principle, that was a plus h. Okay, so here the function is defined as x equals to c. Okay, so then limit x tends to c, f of x equals to f of c. In this case, there will be two solutions. One is left hand limit and right hand limit. Okay, so left hand limit and right hand limit should be equal. for a particular function. Then only if it is equal, then it is called as continuity. And if it is not equal, then it is discontinued. Okay. So directly here you see left hand limit and right hand limit, it is given. So two ways you have to solve, one from the negative side and one from the positive side. Okay. So negative side and positive side both are, if it is equal, then it is a continuous function. Okay. Now here it is given in this form, that is if f of x, in this way question will be can be given. If f of x is, first condition, x plus 1, if minus 1 is less than equals to x, and that is less than equals to 0, sorry, less than 0, it cannot be 0. Okay. Then second condition, x, if 0 is less than equals to x and which is less than equals to 1, but it should not be equal to 0. Okay. Then third condition, 2 minus x, if 1 is less than equal to x and that should be less than equal to 2. So here you see, show that it is discontinuous at x equals to 0, but is continuous at x equals to 1. So you have to take the value of x equals to 0 first. Okay. So first, simply here you see, in one side it is given as plus and another side it is given as negative 1. So f of o or 0 equals to 0. Then if limit x tends to 0 plus, then it will become, sorry. So where I was there, here. So limit x tends to 0 plus x equals to 0. Similarly, if suppose limit x tends to 0 minus f of x equals to limit x tends to 0 minus, if suppose x plus 1. Okay. So x plus 1 equals to 1. So it is the discontinuous function. It is not a continuous, because from the positive side and negative side, both should be equal. In positive side, if you will see that after solution, it is equals to 0, but in the negative side, it is 1. So it is not a continuous function. Okay. Now, some other examples are also given here. Go through that. Okay. Then left hand limit, right hand limit, as I was explaining, that if left hand limit and right hand limit, if they are not equal, so it is not a continuous function. Okay. It should be to be a continuous function, continuity, it should be equal. Okay. So this is the now come to differentiation. Differentiation is nothing but all the formulas you have to by heart it. Okay, whatever formula will be given, you have to by heart it. And differentiation of a function from first principle, starting with the first principle. Okay, so definition, you go through it. Definition I'm not explaining, just I'm explaining the equations. Here you see, according to the first principle, how it is solved. Okay. So limit, starting with limit h tends to 0. Any function, if it is given, if suppose y is a function equals to, that is f of x. So it will be, this is the formula. Okay. Limit h tends to 0, f of c plus h. C is a constant, minus f of c by h. Okay. H here is equals to 0. Okay. Then what you will do, first step is put the given f of x equals to y, whatever value will be given, whatever functions will be given, put the value equals to y. Okay. Then y plus delta y equals to, that is delta means some changes will be there, small quantity of changes. Okay. So f of x plus delta x. Similarly, if suppose y is changing, similarly other side also x will also change. There is a relation. Okay. Then subtract 1 from 2 after simplifying first equation from second equation. If you will subtract, you will get that f of x plus delta x minus f of x. Okay. Now by dividing both sides, that is delta x, delta y by delta x equals to, that is f of x plus delta x minus f of x by delta x. Okay. Now putting delta x, limit x tends to 0, both side. If you will substitute, you will get the final this formula. Okay. Now rules of differentiation. Now constant function rule, power function rule, it is given in this form. Okay. That is formulas are given directly with the examples. Okay. So first formula or first principle, that constant function rule, derivative of any constant is equals to 0. Okay. Derivative of any constant is equals to 0. You can see here dy by dx of 8. Okay. If it is given, then ultimately it will become 0. So every constant, whatever the number will be, if it is a constant, directly the value is equals to 0. All the rules you have to remember. Okay. So rule 2, power function, it will become d of x to the power n is d of x to the power n by dx, that is equals to n into x to the power n minus 1. If suppose x square is given, okay, x square is given, so square, that is 2 is n. So how it will be done? To 2 into x to the power 2 minus 1. Okay. In that way, it will be derived. Then here examples are there. Then rule 3, linear function rule. So according to linear function rule, if suppose function ax plus b is given, that is equals to a to the power d of ax plus b if it is given. So b is a constant, a is a constant. Okay. So it will become a itself. Okay. So here some examples are there. Then rule of sum and differences, it will be again in the same way. Limit, in case of addition and subtraction of limit also, they were distributive. Here also they can be distributive. Okay. Then next rule, product rule, same as limit. Here it can be distributive. It can be distributive. Then quotient rule. Now quotient rule, you just check it here, how it is expanded. Now if suppose d of f of x by g of x is given. Okay. So here in in place of the numerator, how it is replaced. So g of x, the denominator, okay, denominator part, g of x into d of uh, d d of f of x by dx minus f of x first. That means here let me explain 1 by 2. Okay. So 1 by 2 if it is given, so it will be substituted as 2 into d of 2 by dx minus f of x, that is 1 into d of 2 by dx divided by 2 square. Okay. Numerator, denominator. Remember that. Okay. And denominator should not be equals to 0. Okay. It should be more than 0 or less than 0. Okay. Here, as per the quotient rule, it is solved here. Then chain rule, as per the chain rule, it will be given in this way, that is d of y by dx, that is equals to d of y by du into du by dx. Okay. So if suppose some equation is given, if y equals to u square and u is equals to 2x cube plus 5x, that means you have to substitute the function, given function, into u. Okay. Whatever function will be given, f of x if it is given. Okay. So x you will substitute with u and then you will solve it. Okay. Then standard derivatives are there. Just whatever value will be given, direct values are there. So if derivative of log x is given, okay, derivative of log x is direct value 1 by x. Derivative of exponential is itself, okay. Then derivative of a to the power x, it will be given in this way, a to the power x log a to the base e. Okay, all these standard derivatives you will learn it directly. Okay, then implicit, here you see implicit one, that is here finding dy by dx, that is of the following, that is x cube plus y cube equals to xy. In this case, both the side you will find out the derivative. Okay, if linear equation is given, so both the side you will find out the derivatives. Okay, and after finding out the derivatives, just place the same variables on one side and solve it. Okay, some examples are there, you will go through it. Then by using logarithms, some important formulas are there. As per that formula only, you will solve it. These formulas, you remember it. Okay. Then inverse function again, as per the formulas itself, you will just solve it. Okay. Parametric, just check it. Okay. Parametric is not so yet. You can go through it. Okay. Not. Then come to maxima and minima. Okay, that is of higher order. It is the higher order, that means after finding out the derivative of a particular function, okay, after finding out the derivative, find out another derivative, okay, as per the given question. If suppose first order you have found out, that means derivative of first order means only one time you will find out the derivative. Okay, and order of 2, that means 2 times you will find out the derivative. Order of 3, it will go on. Okay, 3 4, it will go on to certain limit, that is maxima and minima. Okay, increasing decreasing, it is given in graph, you can go through it as per the graphs. Okay, then come to, that is application of derivative. It is applied in demand function and supply function. Okay, so how it is given, just the formulas you will see. Okay, all the theoretical parts are there. No certain solution, no certain equations will be there. Okay, just according to the formulas. Some examples are there. You go through it here. Okay, everything is clearly mentioned. Only the basic part I have explained you, and the basic part if you have understood, then you can understand this one also. Okay, directly the formulas are given, and according to that solutions are given. Okay, and according to the economics, whatever explanation is given, okay, total cost, fixed cost, variable cost, all these are given. As per that one only, you will just go through it. Examples are given. Okay, then come to next part, that is simple interest. That you know, I think everybody have come through this simple interest and compound interest. Okay, so this is this should be easiest part for you. All the formulas you have to remember. Okay, simple interest and compound interest, and how they are related with each other, how the formulas are being interchanged. Okay, all the formulas you have to remember, and as per that you have to solve it. Okay, now sometimes what happens, simple interest can be solved by simplifying in rough paper. Okay, so to get the value of simple interest, there is no problem. But in case of compound interest, you might be knowing that log table is used. Okay, sometimes powers are in such a large number that it is not possible to divide or multiply. Okay, so in that case, you can use log table also. If it is provided to you, you can use the log tables while calculating the compound interest. Okay, so some examples you can see here. Simple interest is just the formula, you will just go through it. Okay, I'm just coming to compound interest. Here, if suppose compound interest formula is given in this way. Okay, so here directly amount value is given, amount equals to principal into 1 plus I, that is interest. Okay, interest to the power n, that is number of years or number of time. So here I is the value divided by R. Whatever the rate is given, the rate percentage divided by 100, that is I. Okay, in this example, if you will see that, that is bank pays compound interest at the rate of 5%. Okay, 5% is the rate of interest. Okay, so the value of I here is 5 by 100, 5 divided by 100. Okay, so you can see in solution I is equals to 0.05. Okay, so now here you see, and n is equals to 4. If you can multiply 4 times, then it's okay. But if you are not able to multiply, log table can be used. Okay, here you see, using compound interest table is given. Log table can be used because it is not possible to multiply such a huge number within a given period of time. So you can use the log table. Log table you might be knowing how to read out. Okay. So in this way, all the formulas, according to the formulas, solutions are given. Okay. Yeah, no problem should be there because direct questions are given, but just you have to understand which is the what value. Okay. You can see sometimes amount is given, but you will be confused that as a principal amount. Okay. Compound amount will be given, just amount is given. It is mentioned amount. Okay. You will identify the particular value as amount when amount value is written there. And how to identify the principal when sum is written. Okay, sum is given. So in this question, you see, a sum of money is deposited. That means principal amount is deposited, which compounds interest annually. The amount at the end of 2 years, that is 5,000. Okay, so amount is given 5,000. Yeah, here you have to find out the principal amount. Okay, so in this way, question can be twisted, but it can be easy. Okay, don't get confused. So special cases of compound interest are there. Some other cases are also there. Here you see formula for continuous compounding. Formula is given. Okay, as per the formula, you will solve the questions. Many questions are there. You can solve it and just go through it. Then come to compounding and discounting. Okay. So here compounding and discounting, some discounting formulas are there, how to calculate the rate of interest. Okay, nominal and effective rate of interest. Here is another part, how to find out the interest rates. Okay, formulas again, as per the formulas, you will solve the questions. Here you can see many examples are there. So here you see. Just go through the example, just solve it, you will easily able to understand. Okay. Then present value. So present value meanings also sometimes in short question, 2 marks questions, it can come. Okay. Some examples are there again. Then equation value. So here you see what is equation value. You can see here. Some example is given. Let us see that. In return for payment of rupees 1,200 at the end of 10 years. Okay. A lender agrees to pay 200 immediately and 400 at the end of 6 years. That means it is the case of installment. Okay. Then final amount at the end of 15 years. What is the amount of final payment at the end of 15 years if the nominal rate of interest is 9% per annum converted semi-annually. So in this case, comparison date is chosen to, that is 0. Okay. So the time diagram, as per the time diagram starting with 0 month or 0 year, it is 200. Then after 6 months, Okay, after 6 years, sorry, after 6 years, again it is in the scale, it is mentioned 400. Okay, then after 8 to 9 years, 1200 should be paid. Okay, but it is continued to 15 years. In that case, equation is that 200 plus 400 into 1 plus, that is 0.05, 0.045 to the power minus 1 plus x into 1 plus 0.045 to the power minus 30. Okay, it is compounded semi-annually. That means 15 years if it is given. So in 1 year, 6 months are there. Okay, 6 months are there. That means it will be converted into 15 into 2. That is 30. Okay, and wherever 6 years is given, it is again semi-annually. That means 6 years, 6 into 2, 12. Okay, and rest of the 10 years, that is 10 into 2, that is 20. So simplification, after simplification, you will get this approximate value. Okay. Similarly, some other equations are also solved in this tabular form. Okay. So in tabular form, such examples are given. Go through that, then come to discount. Okay. So discounts are also, some types of discounts are there. So here simple discount, first it is explained. So formula for discount is, that is A into D into T, where discount amount, D is represented discount amount, then amount at the end of T period, that is time, after certain period of time. Okay. Then small d, discount percentage, and small t, time period. So as per that, another formula, that is formula for present value at a discount rate, that is equals to present value equals to a to the power a into 1 minus d whole to the power n. A is the amount at the end of n periods, that means what amount you will get, then discount rate per period, then number of times. Okay, then according to normal rate of discount, that was simple discount, it is normal discount, then effective rate of discount. So various formulas are given, you can see here. Just go through the formulas and solve the equations. Okay. So this is all about today's. So first part is over, that is business mathematics part is over. So in next class we will discuss about the statistics parts. Statistics part, both theories and both numerical parts are also there. How to calculate the regression and that is dispersion, theory of dispersions are there. So you will go through it. Okay. So let's end the class today. Okay. Thank you.